We're going to show videos now on the as driven, why as driven, and how did we get to as driven. We didn't realize it, but we shot 2 videos 6 months apart. And when we looked in the library to start editing, we realized we had 2 of them. And we decided they were both good conversations, but from a slightly different perspective. So instead of editing them out or throwing one away or the other, we decided to give you both of them as a twofer, 2 videos for the price of one. It'll run about 25 minutes long, but we think the conversation is good in both of them, and we want you to see them both. I hope you enjoy it. Okay, here's a question I keep getting asked.
Okay.
What's the big deal about as driven?
Why do you get asked that?
I don't know. People are looking at other alignment machines, they're looking at our machine. We keep advertising as driven, and what is as driven, and what does it make a difference? So I'm going to go back a little bit and discuss a little bit of the history of where I got here. One of the fellows I worked with back in the 80s was working on truck tire wear problems, and it was during the transition period from bias plies to radials.
Did he also have a teal jacket?
A teal jacket? No.
Maybe leather?
No. That was a different guy.
Spiked hair?
Spiked, no.
It was the 80s.
It was the 80s, but that wasn't the guy. No. He was trying to figure out why you could take a truck with bias ply tires and have a fairly flat, smooth pattern. You put radials on and you got all kinds of funny wear.
Okay.
And they said, well, it's just the radial tire. And he said, well, if it's the radial tire and I take 10 trucks and they all work good with bias and I put radials on them and the radial tire's causing the wear, they should all wear the same.
Yeah.
But they don't. Some wear on the inside edge, some wear on the outside edge, some cup, some don't cup. It was a varied pattern and there was no uniformity to it. So he started studying what could cause it, and it wound up getting into maintenance, it wound up getting into inflation, it wound up getting into alignment. And in alignment, we started looking, he was an engineer type, and he was looking for repeatability of readings.
Okay.
If you can't repeat your reading, then how do you know which reading is correct?
Sure. Makes sense.
One of the first things he recognized was that the variation in the reading could be caused by the measuring tools, it could be caused by the truck you're measuring, or it could be caused by the process that you're using when you measure.
Okay.
Which one was causing the difficulty? Is it that with a particular measuring tool you couldn't measure the same thing twice?
That would be a problem.
Or was it that the process you used to mount the equipment changed the reading?
Okay. Or was it the truck, because trucks just aren't possible to measure correctly?
And that's where he got into the as driven.
As driven.
He recognized that the truck is not a solid, rigid piece.
You better not tell Cat that, because they spent a lot of money on that thing.
I think it's a solid, rigid piece, and it's not. You have play in the bearings, you have play in the kingpins, you have play in the tie rod end joints, you have play in the spring bushings, you have play in the rear suspension tracking arm bushings, you have play in the airbags. And if you put a truck on an alignment rack, and then you jack it up in the air and let everything droop, mount instruments, dial out, run out, set it back down on the rack, each time you jack it up and set it down, you'll get different readings.
Really?
Yes.
Different readings?
Different readings.
How much different? I mean, are we talking about thousandths of a degree?
No, we're talking about some significant changes. Just looking at toe, for example.
Okay.
I've personally seen vehicles that were a 16th towed in with one reading, jack it up, set it down, now it's an 1/8 out.
Ever?
Ever.
Or often?
Well, frequently we'll get changes of a 16th to a 1/4 of an inch.
Actually, let me rephrase that. How often do you ever take a measurement, pick the vehicle up, put it down on turn plates, and get the same measurement?
Less than 10%.
Less than 10% of the time, you could repeat the measurement by lifting it up and putting it down.
Yeah, that's my experience.
Okay.
recognizing that it could be the vehicle that's causing the changes or it could be the equipment causing the changes, he went to as basic a measuring system as he could, a tape measure, and some simple marks on the tires.
Right. If you can't get a tape measure to repeat
within a 16th of an inch,
16th
that's
of
all
an
he was looking for.
You've got problems.
And he found that jacking it up and sitting down on turn plates, he didn't get the same readings.
Did not.
But if he took the truck out and drove it in on a hard surface and rolled it to a stop with the drag in the tires positioning all of the play,
Okay.
and then didn't jack it up and measured it, he could repeat readings.
And then backed out again.
Drove it in and got the same reading.
And then backed it out again, rolled it in.
Same reading.
Somehow, when it's rolling forward, it just keeps on ending up the same.
Correct. Readings within a 16th.
That's sort of what we're trying to do.
Which was better than he got on turn plates at any time.
And then even yes. So now, to be fair to our friends out there, if you were to take a vehicle, pick it up, put it down on a set of turn plates, take a measurement, take off your measuring equipment, pick it up, put it down on turn plates, and take another measurement, could you repeat?
You could.
In that condition.
You could, but the question is it probable or possible?
Okay.
It is possible, but our experience with the equipment is it's not probable.
Okay.
Okay?
And the other issue being, if you can repeat measurements in that condition, how does that relate to the tire wear?
Well, see, that's the next half of the discussion. If you measure a vehicle in artificial conditions, and if you could produce repeatable readings for tow, as an example, then when you take the vehicle and drive it, is the tow the same as what you got in this artificial condition? Our judgment of that was based on the tire wear.
Why tire wear?
Because that's what we're aligning a vehicle for. We
No,
don't.
are you sure we're aligning it for the tire wear? Are we not aligning it for the engineering standard of a repeatable measurement?
No, we don't care about the repeatable measurement.
As
We don't care
well
about the
as-
printout. We care about the tire wear.
So if the repeatable measurement doesn't match the tire wear,
You got a problem.
didn't get it.
You haven't solved your problem.
Okay.
So if the tire says it's towed out, our measurement should say it's towed out. If the tire says it's towed in, our measurement should say it's towed in. If our tire says the tow's right, our measurement should say the tow's right. And if it does, then we're good. With that as the goal,
Okay.
we found that measuring the vehicle as close to its driven condition produced the best consistent results. Perfect? No, nobody's perfect. But a probability of accuracy instead of a possibility of accuracy.
Have you been able to measure a vehicle while it was driving?
Well, there are some systems out there, very expensive engineering systems, that are capable of doing some of those measurements.
Some of that.
None of them are practical for a routine alignment or for a fleet alignment. So
I see.
we've kind of let that set aside.
The point, yes. Very important recommendation there being, we're also trying to get this work done on a daily basis.
Yeah, for regular people just trying to align a vehicle. So what we found for the purposes of as-driven measurements, the more complicated we made the system, the more turn plates we put in, the more racks we put in, the more wheel clamps we put in, the more compensation on run-out you have to deal with. The more of that stuff you did, the further away you got from a practical, repeatable measurement.
Okay.
Okay? And that was our goal. The second thing we learned was, if you brought a vehicle in, and now I'm going to talk about measuring drive axle alignment.
Okay.
We're going to talk about thrust. Which way is the axle aimed? Whichever drive axle it is. You set it still. You measure with whatever device you want.
Sure.
You would adjust until the measurement device said it was correct. But then if we rolled it out and rolled it back in, the measurement probably would be different.
Okay. Now, do you know that it's not different because of run out? Or is it not different because of the condition?
Now we were able to use various methods, including marking the tires to measure in exactly the same spots, and using different tools in the same vehicle in order to confirm that
Taking multiple measurements in different positions as you roll forward.
Yeah, there's all kinds of ways to do that.
Right.
That we verified the fact that the measurement itself had changed.
the measurement changed.
We also-
Sometimes it didn't change enough.
Yes, sometimes it didn't change at all. Sometimes we would adjust one axle and lo and behold, the other drive axle would change. So how can this happen? We put the shim in the front axle. Why did the rear one move? What we learned was that even bobtailed, there's 4,000 pounds sitting on the front drive axle, there's 4,000 pounds sitting on the rear drive axle.
Okay.
Those two axles are mounted to the truck using rubber bushings and airbags, movable compliant components, and those two axles are fighting with each other over control.
Okay.
And one axle can be actually pulling the other axle toward it because they want to roll together. They don't want to fight with each other.
So that
So
means
it's
that means different suspensions react different ways.
Absolutely.
Absolutely. So
Kenworth 8-bag will respond differently than a Flexair. Flexair will respond differently than a Freightliner.
a 2-year-old Freightliner will respond differently than a brand new Freightliner.
Correct.
So how do you know how to compensate for the suspension that you've got just by sticking in the shims?
Well, what we found was practical was to measure the vehicle as driven, measure the two drive axles as separate entities, put the shims in that we feel were appropriate to get it where we wanted.
Right.
But then we had to back the truck out, drive the truck back in, and let the two axles do their fight, play with their bushings and their movable compliant components, and see where they settled. And if it was where you want it, great, you're done. If it's not, now I got to shim a little more, back them up, pull them in, and let them settle their differences
Until your measurements,
Or
your
where I-
as-given measurements, say that the axles are where you want them.
in the range that we find a high probability we'll get the tire wear and handling we expect.
Now, this sounds like a lot of work to go through just to get the measurements you wanted, because when you did it the first time you got the measurements you wanted, if you were using another system, you got a printout that you wanted. There wasn't that in alignment.
No.
Why not?
Producing an alignment doesn't necessarily produce tire wear. If the goal is to produce a printout that looks pretty, that's one thing. But the goal that the customer wants is to produce a vehicle that's going to wear tires right and handle right.
We should hope
And
that
so
the
we-
customer is aiming for tire wear and handling.
Well, I don't have to hope that. 35 years shows me that's what they're looking
That's
for.
what they wanted.
Okay.
Okay.
So we find that this as-driven verification is necessary to make sure that it settles down, because the proof of this is in the pudding. And the pudding that the customer looking for is the tire wear, not the printout.
He doesn't want a printout. He
Now,
wants-
having said that, I'm going to take this one more step.
Okay.
People have often asked me, why don't you computerize your system? You have a very basic analog system. You read
It
the
is
lasers on a target.
I've been building them for quite a few years, and I can tell you that it is not computerized.
And there are four main things that have caused me not to want to take that step. The one is, yes, we can computerize the targets. We can make the laser read directly into a computer. We could use Bluetooth and Wi-Fi to hook it all together and make it look fancy. But nothing that I have done has increased the accuracy of the system.
Okay.
And it does double and triple the cost of the system.
So the system that we are using right now, the system that we've been building and selling for years, is as accurate for taking these measurements as you could really want for what we're trying to accomplish, which is as-driven alignment and the best tire and handling you can get.
Within the standards that we've been able to come up with, it's the best that we've seen, and it proves itself. So why should I increase the price of the equipment double and triple? Why should I reduce its durability? Because you do all that, it's going to be more fragile.
I tell you, this system does last a long time.
Yeah, so we haven't been able to justify it. It won't even work any faster. In fact, with the computer stuff, it actually works a little slower.
You've got to set all the computer stuff up where you
Right.
can take a measurement very quickly. The setup and measurement time with our system is
6 to 10 minutes, and I'll measure a 3-axle truck.
on the outside. It takes a lot longer to actually do the alignment than to take the
Oh
measurements,
yeah, depending on which rusted or boast.
even if it wasn't.
So, having said all this, what we're trying to accomplish is good tire wear and good handling. Toward the objective of good tire wear and handling, we found that measuring the vehicle in as close to its as-driven condition as possible, adjusting it and then backing it out and remeasuring it as driven to verify that it's right, is what produces the consistent results we're looking for. So why measure a truck and then every 6 months have to remeasure it because you didn't get the tire wear? Where if we can do it right and take an extra 15 minutes or 20 minutes, we wind up getting 150, 170, 180,000 miles out of the steer tires, and we don't have to align it as often.
So really, another way of looking at this is these tires are capable of getting incredible steer tire mileage if the truck, in fact, can hold that alignment for that long.
Yeah, they hold
and
them.
The proof is, the truth is, the truck will hold the alignment that long.
Yeah, we see it consistently 180.
180.
Some cases more than that, but
XZ83 is a very good tire for getting upwards of.
Well, so's the Continental
617,
HSL, and so's the 399 Goodyear,
399,
and
yep.
so's the
280.
Bridgestone 280 and 287.
Yeah, there's a lot of really good tires out there that are not seeing the upper end of their possible life, and we're talking by tens of thousands of miles,
Right.
Because they're just not aligned right.
So that's why we do as driven. Thank you very much. Okay, the subject today is as driven measurements. We use that term, that phrase in our company slogan and our advertising. It's a main focus in our concepts on a measurement. So what is as driven and why is that important? If you look at any front end on any truck I've checked in the last 40 years, you'll find a little play in the steering components, a little play in the tie rod end joint, a little play in the wheel bearing, a little play in the kingpin. If you look at the rear suspension, you'll find play in the bushings and in the airbags that hold it in place. Now, as you drive a vehicle down the road, drag builds up on the tires, and the drag pulls the tires toward toe out on a steer axle normally, sometimes toward toe in, and it'll push and allow the fight between the two drive axles to change their thrust measurements, their alignment relative to the frame. We believe that this is an important aspect in the net result for tire wear and handling. There are many alignment machines out there that don't recognize this and don't deal with it at all. They'll use turn plates, bring the vehicle in, park it on a nice free-floating turn plate, jack the front end up, mount instruments, dial out, run out, set them back down, and measure them in what they call a relaxed condition.
Relaxed. Now, just to be sure what they're trying to accomplish by measuring it in a relaxed condition. Are they trying to bring it out of its operating condition or return it to its operating condition?
They're trying to measure it in what they call a neutral position.
Neutral.
Okay? So everything is neutralized, and then they want to set the alignment.
Okay.
I've never seen a truck wear out tires in a neutralized position.
No, they don't drive on turn plates typically.
Correct.
They drive on a road.
Now, one of the questions that can come up is how big a change can this make between driving a truck straight into a shop and rolling it to a stop on hard surface and measuring the toe without lifting it versus putting the vehicle on turn plates, either by driving onto it or jacking it up and putting the turn plates under it. If we look at just the tie rod end joint and we look at the manufacturer's manual on how you're supposed to check a tie rod end joint, we have a steering arm and we have a ball joint and the tie rod is attached to it. The procedure listed in the Dana manual for checking this is that we're supposed to put a dial indicator on the outside of the steering arm and put the contact on the outside of the ball. Then they're supposed to wiggle the steering wheel back and forth, and while doing this, somebody's supposed to observe the dial indicator needle and tell you how much movement you were getting. They don't indicate that it's required to check it up and down. They don't care about rolling it fore and aft. They want you to check it this way.
Just sideways.
The amount of movement that is acceptable according to the manual from Dana is 40 thousandths movement.
40 thousandths of an inch. About 1 millimeter?
I don't know about millimeters, but I know 1/32 of an inch is 30 thousandths.
Okay, so a little more than a 30
A
second.
little more than a 30-second.
Okay, and that's on each one.
On each one.
Okay.
Now, crawling underneath the truck without the dial indicator and the guy's wiggling it back and forth says, do you have any movement? You wouldn't see a 32nd of an inch.
No.
Okay. But the dial indicator will show it. Now, if this steering arm that's attached to this tie rod ball joint is 12 inches long from the spindle to its connecting point, and if it's able to move in and out 1/32 of an inch,
Sure.
how much is the 4-foot tire moving?
In other words, you're saying that spindle end, if it moves a 32nd of an inch at the spindle,
At this ball joint.
yeah, at the ball joint, it's not actually at the spindle, but it's very close.
Well, it's 12 inches away.
12 inches away. At this distance compared to the front, how much movement is
We've
there?
got an overall 4-foot movement in the tire, so the total toe is changing 4 times that.
4 times the 1/32. So upwards of
An eighth of an inch
per side.
Correct.
And that would be an allowable amount of tolerance.
According to them, a new ball joint can have 30 thousandths movement.
Okay.
So the toe can change with new ball joints 1/4 of an inch or more. So if I set the toe jacked up and set down on turn plates at a 1/16 of an inch toe in,
Right.
and I drive it off and the drag hits it, how much can the toe change?
Upwards of 1/4 of an inch.
Correct. Now typically it won't change that much,
No.
but changes of a 1/16 to an eighth of an inch are very common.
Very common. Yeah. It's very true.
Okay.
I've seen it.
On the rear end of the truck, sitting still, each axle is carrying about 4,000 pounds of weight. And those two axles, as they drive down the road, are fighting with each other because one's dragging sideways, one's going straight, unless you have them absolutely perfectly aligned, and that doesn't happen.
Even using, again, 32nd of an inch shims set inside of the,
You're not going to get them precise.
you're just not going to do it.
So, if you measure them in a neutralized state, you don't know where they're going to wind up going when you start driving them.
Okay.
If you were off on your measurement of your drive axle, 1/16 of an inch shim. Now, on our system, on the rear drive axle to the front, using the laser, that would be off 1 inch on our laser.
Okay.
On a Hunter machine, that would be about 0.06 degrees.
Okay.
Sounds like a small number.
It is.
On a Joe Sam machine, that would be 1 millimeter per meter.
Yeah.
On a Beeline laser, shooting their single laser up to the front, it would be about a 1/2 inch.
A 1/2 inch.
Where on ours, with 2 lasers, it's off 1 inch.
Still, it's only an inch.
It's a small amount. But it means that you're pushing the steer tire sideways 1 inch every time the vehicle travels its own 250-inch wheelbase.
1 inch every time it travels to, but it's only 1 inch.
Correct. But I got to use a calculator for this. If we take the 250-inch wheelbases on the truck,
You know, your math teacher told you that you wouldn't be carrying a calculator with you.
my math did teacher tell me that, and I was supposed to count on my
You're
fingers,
supposed to know all this
but I
stuff
can't
in
do
your
it.
head.
If we take 5,280 feet and we multiply that times 12 inches,
Okay. To get to your number of inches.
and we divide that by 250 inches,
Okay, get the length of a.
that means 253 times that 1 inch will be occurred. So it's going to push the tire sideways 253 inches
Inches
every mile.
every mile. Okay.
Now, if we divide that by 12, it's going to push the tires sideways 21 feet every mile you drive.
21 feet a mile if it's off by 1/16 of an inch on the rear drive axle.
Correct.
1/16 inch shim.
Correct. Now, if we multiply that times 30,000 miles of driving, it's going to push you sideways 633,000 feet.
Inches.
This is feet.
Oh, we're up to feet now.
Yeah,
Yes,
it's
we are.
21 feet.
You're right.
Okay. Now, if I divide that by 5,280, okay,
Yeah.
in 30,000 miles of driving, I will push my steer tires 120 miles sideways.
Push your tires 120 miles sideways because you're off by a 1/16 of an inch every 30,000 miles of travel, which is 3 months.
Nobody's steer tire is designed to go sideways that much.
Sideways.
The difference in precise measurements between a as-driven or a relaxed setting can accumulate to this kind of difference in lateral drag, which accumulates to that kind of difference entirely. This is why we're so concerned about not mounting to the rims. Don't jack up the wheels to dial out, run out. Don't set it on turn plates. Measure it in its driven condition. Make an adjustment, then back it up, pull it forward, and make sure it's right, because those small incremental changes accumulate to tire life.
Some small change then can occur between the adjustment that you made and when you backed it up and rolled it forward and rechecked.
Yeah.
Some small change could be there. You can be wrong when you did it the first time.
Yeah.
We are very used to making the adjustments ourselves. But when you know you have to adjust that toe by 1/8 of an inch toward toe in, you make your adjustment, you don't know that the truck agreed with you. You got to back it out, roll it in, and recheck. If you can't recheck your measurement and get what you wanted, you didn't really do the alignment.
Yeah, sitting it on turn plates and watching it in a neutral condition doesn't tell you what the toe or the drive axles will be when you're driving it.
Exactly. If you can't recheck it, you don't know.
Correct.
That's why the as-driven method that we use has been so, we believe, has been so successful.
We've got proof that it's been successful.
Pretty much got proof.
So that's where we're at. That's why as driven. Thank you very much.
What kind of proof did we have?
What kind of proof?
Schneider, maybe?
Schneider, we took them from an average of 60,000 miles
on a test set
to an average now of 180,000 miles on steer tires.
Oh, that's in general.
Yeah.
Yeah. Now, you don't have as many trucks and you don't buy as many tires as Schneider does, I'm sure.
But it's all relative value.
It's all relative value. The point being, we saved them a lot of money just by making this one small change in how they...
The method of measurement, as driven, and the settings changed the tire life.
Yep. Okay.
Thank you very much.